Let's be real. AI is changing everything: research, creativity, how we live, how we work. But here's the catch: it runs on a hidden engine, massive amounts of electricity. Data centers, the digital power plants behind every AI model, are projected to double their energy consumption by 2030, rising from 415 to over 940 terawatt hours globally. Training a model like GPT-3 alone, it consumes about 1,300 megawatt hours, roughly what 130 US homes use in an entire year. That's not just a stat, that's a system strain. As AI tools get smarter and more widespread, the energy bill will only grow, along with our responsibility to find better, cleaner ways to power them. Here's the big move. Google has partnered with Elemental Power to build 3 advanced nuclear plants in North America. Their goal? To fuel AI's rising demands with stable, carbon-free electricity. Google is covering early-stage investment, site scouting, permit applications, and identifying the right reactor types. Elemental, on the other hand, is exploring advanced designs that prioritize flexibility, safety, and scalability. Each plant is expected to produce at least 600 megawatts, enough to power hundreds of thousands of homes or multiple AI campuses. This isn't just about powering search engines, it's about future-proofing infrastructure for decades. And Google? They've already secured the option to purchase the electricity once those plants are online. Let's talk nuclear tech. The next generation of reactors isn't what you imagine from old black and white documentaries. Enter small modular reactors, SMRs, compact factory-built units that can be scaled as needed. They're quicker to deploy, safer by design, and ideal for decentralized grids. Also in play, fast neutron reactors, which can recycle nuclear waste as fuel, turning yesterday's problem into tomorrow's power source. Of course, hurdles remain: steep construction costs, complex licensing, and public skepticism about nuclear safety and waste disposal. But these designs aren't stuck in the past. They're designed for a smarter, cleaner energy future. AI isn't just consuming energy, it's also revolutionizing how nuclear plants operate. Think predictive maintenance. AI crunches real-time sensor data to flag issues before they become emergencies, or reactor monitoring, temperature, pressure, flow rates. AI tracks it all, reducing risks and improving response times. And then there's the concept of digital twins, virtual replicas of entire power plants used to simulate events, test upgrades, and train personnel in risk-free environments. In essence, AI is helping nuclear power become not just more efficient, but also more resilient and safer. None of this happens without the right policy environment. The Inflation Reduction Act offers generous tax credits for nuclear projects, reducing risk and attracting investment. Meanwhile, the US Nuclear Regulatory Commission, NRC, is introducing a technology-inclusive licensing framework to streamline approvals for next-gen reactors, cutting timelines from 7 years to as few as 3. Still, public perception remains a barrier. Safety fears, past incidents, and misinformation often overshadow the major advancements in reactor design and risk management. That's why political will and public education are just as important as engineering breakthroughs. Google isn't alone. Microsoft is working with Constellation Energy to revive part of 3 Mile Island for AI data operations. Amazon is exploring renewable integrated data hubs in Brazil, where over 90% of the power grid is clean. According to Elemental CEO Chris Colbert, nuclear power is key to future-proofing AI, not just powering innovation, but doing so without sacrificing the planet. In short, the future of AI won't just be decided by algorithms, but by how we choose to energize them. If AI is the engine of the next industrial revolution, energy is its fuel, and nuclear may be the cleanest, steadiest supply we've got. This isn't about choosing between progress and the planet, it's about designing systems that serve both. Strategic investments in clean, reliable power aren't optional, they're critical infrastructure for a digital world. So, as we build smarter machines, let's also build a smarter energy future, one powered by foresight, innovation, and responsibility.